Welcome to the Microservices Image Processing Server app portion of Assignment 2. The purpose of this assignment is to deepen your experience using Java functional programming features and their integration with Java parallel streams and Spring microservices. In particular, for this assignment, you'll develop a server app that uses Spring WebMVC to create microservices that receive images from clients and return updated images after applying requested transforms. Unlike the earlier assignments, the code you write here will not have its own GUI. Instead, it will be accessed via an Android client app that can either perform all image processing locally on the client device or remotely using microservices deployed on one or more servers. Please use the Android client app portion of Assignment 2, along with the unit tests discussed below, to help evaluate and debug your solution. The following resources may be helpful in completing this assignment. A tutorial overview of Spring WebMVC and its support for microservices appears here. Naturally, we'll cover all this material in class. The Microservices Image Processing Server app is packaged as a project using the latest version of IntelliJ. This app is written in Java and demonstrates many Spring WebMVC capabilities. For the purpose of this assignment, however, you only need to be aware of the following directories. Source main Java server, whose main and microservices comment folders contain the skeletons you need to fill in, as described below, and source test Java, which is a set of unit tests that exercise key features in the server and can be used to help evaluate whether you've correctly satisfied this assignment's requirements. To compile this code, you need to use the provided IntelliJ project. You can start all the microservices that are part of this project by clicking the green Run Microservices button or by starting each microservice independently via the IntelliJ IDE. You'll need to modify several files containing the Java skeleton code by completing the to-do uFillInHere task to provide a working solution. Do not change the overall structure of the skeleton. Just fill in the to-do tasks, and do not delete the to-do tags. In particular, you need to finish implementing the following to-do tasks for this assignment in the source main Java server folder. Main controller.java and main service.java, where you'll need to complete the to-do tasks and various methods that implement an app gateway entry point for remote clients that want an image to be processed by a set of image transforms via Java parallel streams. Transform controller and transform service.java. You'll need to complete the to-do tasks here and various methods that implement a microservice entry point that transforms the image by applying a transform operation, thereby producing a new modified image that is then returned to the client. Your solution should use no loops or any unnecessary conditional statements in the assignment, and instead use Java parallel streams, operations, and functional programming. Your solution will be considered correct if it passes all the unit tests and communicates properly with the Android client app. Skeleton code for this assignment is available here in the server folder of my GitHub repository. You can pull this skeleton code into your repository, read it carefully, and complete the to-do markers. Unit tests in the source test Java folder are provided to increase our and your confidence that your implementation is working as expected. As usual, testing only demonstrates the presence of bugs, not their absence, so don't rely solely on the unit test to detect problems in your code. This client-server assignment is more complicated than the previous assignments, since it requires deeper knowledge of Spring WebMVC's annotation-based approach to remote communication. Therefore, please start the assignment soon and ask questions in class, office hours, and on the discussion forums. As usual, the Microservices Image Processing Server app skeletons and unit tests are extensive, though you don't need to understand them all to complete your solution. Now that we've walked through the specifications for the server portion of Assignment 2, it's time to turn our attention to the skeletons. And we're going to start with the main controller. This is the portion of the server that's going to take incoming post requests and then convert it into an endpoint method call, and then do the processing by delegating to the service to do the processing through parallel streams. So down here, you can take a look at the apply transforms method. This is the one that you have to annotate. You'll need to add an annotation here to indicate that this is an endpoint method that can handle post requests. And in order to do that, you'll need to put the right annotation there. And you'll also need to go and put the right endpoint string, which you can see by finding the appropriate versions that are defined here in the constants file. So that's one thing you have to do. You have to add that. And then the second thing you have to do is you have to add the appropriate annotations for the parameters. So we have a list of strings, which is the list of transform names, and also a multi-part file. And so you'll need to find the annotations to use here. And I'll give you some hints. They have to do with requests and request parameters, and they have to do with requests and request parts. So that should give you a hint. Then down here, you need to actually implement the call that will forward to the image service field and call its apply transforms method with the appropriate parameters. So you'll have to take a look and see what is available on the image parameter and so on, and see what's used by the service. Speaking of the service, let's go ahead and take a look at main service. So you can see main service is the portion of the program that's going to actually do the work. It's going to essentially make the calls, and this is where the bulk of the logic goes. There's some code that's already provided for you. We've got an auto-wired REST template, which is actually implemented over here by the bean in the components class. And over here, we also have a discovery client, and that's something that's implemented as well. You'll have to know how to use the discovery client. We'll talk about that in class, of course. Over here, we have something called base URL, which you have to use for some of the things. I think I actually provide you with this code. Here's the main entry point method. This is the apply transforms method. This is the one that actually does the work. And as you can see here, I give you some descriptions of what you need to do in this implementation. And so what you're going to need to do is basically take the list of transforms and turn it into a parallel stream. And then you need to use an intermediate operation to call a helper method that will build the request URL for this particular microservice for each of the different microservices, because there'll be different ones in that stream. And then you'll have to go ahead and skip any transforms that have no matching running microservice. This is by using filter, as you've gotten used to doing. And then the next thing you do in the sequence is, again, you'll use an intermediate operation to send a post request to the service, and you'll have to pass in the appropriate parameters to do that. You'll have to pass in the URL and the bytes and the file name and so on. What will come back from post request will be a result, and then you'll skip over any results that have failed. If for some reason the microservice couldn't actually do the processing, you'll have to get rid of nulls as usual. And then the final thing you'll do is you'll collect all the transformed images into a list, and you'll return that from apply transforms. And of course, that will then end up going back to the appropriate call in the main controller, which will then take that and return it to the client after first internally encoding it as JSON. You don't have to do the encoding, of course. That's what's done for you by Spring and Spring WebMVC. Let's go down and take a look at some of the helper methods here, some of which you have to implement, some of which are provided for you. So here's post request. Portions of this are provided for you. So we make a multi-value map, and we go ahead and make a byte array resource, and then we put that byte array resource into the map under the name image. And then there's some other things that you need to do at that point. You're going to have to use the REST template field, and you'll go ahead and basically post the request and return the resulting transformed image. And so there's a method that you would call on the REST template in order to do a post request on a given entity. And you'll pass in the URL and the map, as well as the class type of what you want the result to come back as. So you should think carefully about what that would be. And then after you get the result back, you'll get the body of that result, and that will be what's returned as the return value of post request. And in the body of that result is going to be a transformed image. And we'll see that when we take a look at the microservice implementations here in a second. You'll have to fill in a couple lines of code here to do that particular work. Here's build microservice URL. I believe I provide all the code for this. It's a little tricky. It basically goes and calls get transform microservices, which we'll look at in a second. That's a little helper class down here that you have to implement. And get transform microservices is going to use the discovery client to get the list of all the microservices, and then you convert that list into a stream. So it's a pretty simple little helper method, but that gets you a stream of the microservices. And then we provide the rest of the code. You filter out the microservice names if they match what we're trying to search for. Or sorry, if you filter them out, if they don't match, if they match, you go ahead and let it go through. And then we construct what's called a redirect URL for this particular transform microservice. And again, this is some subtle logic that we provide, but essentially we're going to take the base URL and add the name of the transform in lowercase, and then we're going to go ahead and construct something that will call the apply transform endpoint method in the corresponding variant of the microservice, sepia, tint, grayscale, and so on. And then we pass in the transform name. And we'll get back the first element because there's only one thing that comes back from that. And if for some strange reason there's no running microservice or something fails, we'll return null. So that's code you don't have to write, but it's good to know how that works. And then we looked before at get transform microservices. So let's take a look now at how you actually implement the microservices stuff. So the way that that works is we come over here and we take a look at the transform controller. And as it says here, the transform controller is what's actually the front end to the transform itself. And we have several transforms, and these are going to basically transform the image by applying the corresponding transform operation. And that will thereby produce a new modified image that will ultimately be returned back to the client after it's consolidated by the main controller. So take a look here at transform controller. You can see that we have an auto-wired transform service. We'll take a look at that in a second. And here's the method that you have to implement. This is, or actually you have to flesh out. This is the apply transform method. As you can see here, you're going to again have to add the appropriate annotation to allow it to handle post requests. And you'll also have to add the appropriate annotations for the string parameter and the multi-part file parameter. You could actually omit the annotation for the string. That's a primitive type, so you don't have to annotate it, but it doesn't hurt to do that. You will have to provide the annotation for the multi-part file. And those annotations are very similar to what you would have done on the main controller annotation for the apply transforms endpoint method. And then we go ahead and call apply transform, passing in the appropriate elements that are obtained from calling these helper methods. You don't have to write those helper methods. So let's now go ahead and take a look at the transform service. This is really what does the heavy lifting here. And so the transform service, as you can see, is going to basically perform image transform operations. And of course, there are 3 different operations we support here. And so this service is going to have to figure out which one is being invoked at this point. To do this, we're going to use a very clever technique that I love to do all the time, where we're going to make ourselves a map we call mTransform map. And it's going to map the name of the transform, like grayscale or sepia or tint, to a function that will perform the transform. And so we're going to basically have you initialize this transform map by putting in the appropriate names. And once again, you can get those names by looking at the constant file. You can see here we've got string names for the various types of transforms. And so you enter those in the constructor, in the map, and then you also will put in the appropriate method reference that will do the transform. So you'll have a method reference that transforms grayscale, you'll have a method reference that transforms sepia, method reference that transforms tint, and you can find those methods if you look further down in the file. What you'll be implementing also is the apply transform method, and in this particular case, you're going to do a couple things. The first thing that you're going to do is you're going to go ahead and come in here and use the transform map to find the function that's associated with the transform name. So you'll basically just look up in the map using the appropriate lookup operation on a map, and that will give you back the function. And then you'll apply that function passing in the transform name, and that will then go off and do the transform with all the other information that we've got there. If things go wrong, then you're going to throw some exception. Otherwise, you'll apply the results and get the results. And then the last thing you need to do here is fill in the code that will take the image name and the transform named and the buffered image results and create a transformed image object. And that is what's going to get returned from this particular method, from the apply transform method. If you look down here, you can see the various methods that do the transforming, grayscale transform and sepia transform and the tint transform. And of course, these are the methods whose method references are going to be initialized in the transform map up in the constructor. So that's basically the different pieces you'll have to implement for the server portion of assignment 2. Now that we've walked through the specifications and the skeletons for this app, let's go ahead and show you how to run the unit tests. As usual, we'll come down here and look at the test folder, and then we'll go ahead and click on Run Tests. And this will go ahead and instantiate the various unit tests, which use some cool sophisticated mocking technologies to run the tests. As you can see, it tests both the controller and it also tests the service, and it also tests the other pieces of the app, including the microservices. And if all goes well, you should get a nice green check mark, which indicates that things work the way you expected. If something goes wrong, then of course you'll get an error diagnostic indicating that something is amiss, and you'll have to go in and fix it. Now that we've walked through the specification, the skeletons, and shown how to run the unit tests, let's go ahead and show how to launch the server portion of this client-server app. What we're going to do up here is come and choose the microservices multi-run configuration. If you want to see what the microservices multi-run configuration looks like, just click on Edit Configurations, and you can see that this includes running the Eureka application, which is the discovery client, the main application, which is the main entry point into this backend server, and then it runs 3 microservices: Grayscale microservice, Sepia microservice, and Tint microservice. What we can do then is we can go ahead and click the green Run button, and that will start and launch all of those services. And it does it in the order that was specified. So you can see here it's first launching the Eureka application, which is then used as a discovery client for all the other microservices. It then begins to run the main application. As you can see here, the main application is listening on port 881. Whoops, that disappeared. There it is, 881. And then the other microservices are started, and they're going to be listening on other ports, and those ports will be randomly assigned and registered with the Eureka discovery client. And so these microservices will then be discovered by Eureka, and that will then make sure it forwards the request to the right place. So what we're going to do now is, if you go and watch the client video, you'll see how the client application, which is an Android application, is going to run. And when we do that, we'll show you how the client actually communicates with the backend server and the services, starting with the main application and then continuing on to find the appropriate microservices based on the requests that are being made from the client.